Hello, welcome to the podcast where I explain the linear patterns with 2 points app that I made. One thing that I want my students to be able to do is understand that given any 2 points, we can create a linear pattern that contains those two. To do that, each point here has input and output lines on it. So what I'm doing in my class is I'm relating with our sequence talk, I'm extending that to term values. So like this point A here, which is at -2, 2, would be like the negative second term, which I know doesn't make sense in sequences, but we can extend patterns going past, the first, second, third, fourth, fifth, and so forth. Why can't we say, the 0th term, negative first term, negative second, so that they can extend patterns backwards? So in this case, a couple things. I want them to be able to understand that this would be like the negative second term, and the term value happens to be a positive 2. This is the fourth term, so maybe like if we were to create a list, negative second, negative first term, 0 term, first term, second term, third term. Our fourth term has an output of 4. So they need to understand, I think, that we need to figure out to understand, the slope or these other terms in between so that we can get the equation. We need to know what the 0th term is so we can get our y-intercept. And then we also need to know consecutive terms here so that we can get slope. But we can also get slope from looking at going from A. So if we go up 2 and run from -2 to 4, which is 6 in this case, we do have a slope of 2, 6, or a third. So they can get the equation for the line being a third plus, but they don't know what the 0th term is. So what I want my students to be able to understand is that, let me delete this pen stroke here. So what I want my kids to understand is that to get from the negative second term to the fourth term, there's really going to be a bunch of terms in between. So when we keep the change of x here to 1, this is going to give us, in between our points here, the terms that have a difference of 1, which is like a sequence. So what I decided to do with this app was make a few checkboxes here. These points, by the way, there's two ways you can move them. You can just click and drag the points if you want to. So you can just move them wherever. Also, you could just change the ordered pairs in the boxes here too. Okay, so what I have are 3 checkboxes here. Show directions between points, which are vectors. So what I like about this is it shows us the vector to get from A to B, the translation, with the vertical and the horizontal components of how to slide or translate from point to point. So I color coordinated to go from A to B, which is the green. We'd have to go up 2 and then to the right 6. To go from B to A, we would have to go down 2 to the left 6, which gives us that negative over negative. So when we do actual slope conversations, when we say it doesn't matter which y coordinate we choose first, this is really y, showing us a good reason with a rectangle. Okay, and then the vector being the diagonal, there's some good geometry going on in here, so it makes, at least for me, a good way that I can see relating my geometry to algebra. So anyways, we got the directions here. Now, show points in between A and B. So this is where I want to find those extra sequence terms here. So really, here's our 0th term. Okay, we could zoom in if we want on this and see what it happens to be. Oh, and it happens to be 2.5. So now we got our rule. We've got y equals 1/3 x plus 2.5 based off of the 2 points that I chose. But they can see the terms in between. Now, density is always a conversation that I want, because domain values, I've been using a lot of just whole number domain extending into the negatives, but I want my kids to also understand that we could put in, this is what helps us with function, but getting, the -1/2 or -1/3 or positive 2.47, as an input, it's got to have an output to it also. What I like is that this change of x, we can actually make the change of x smaller than 1. So as we do that, notice now we get a whole lot more points, which as I change it to 0.05 is our change in x, you can see all these points in here. right, which have an input-output pair as well. So the density of our line, and as we change our points around, those will stay. And they can understand, I think, that there is a line or a linear pattern here with our domain values and our inputs that aren't just necessarily whole numbers. Okay, so I like that we can change and show density, but also I thought about it's important not only can they see the terms in between, but they can also extend the pattern. So when they click on show points that extend patterns, then we can see the line getting extended from those 2 points. Okay, so not only can we show density in between points, but as we change our x, it'll show density outside of our points, which basically if we scroll out, we can see that we have a whole lot of points that we evaluated for that have input-output pairs. So when we do function talk and we're putting in values that aren't nice whole numbers, students should be able to understand that this is possible. And they can see here that if we input different numbers, we get the density, hence the line that we draw. Because I really want my students to understand that when we connect 2 points with a line, that line means something, and it's every single input-output pair, all the real numbers, domain and range values that we get. So this app, you can change wherever you want your points to be, and we can evaluate how to get from one to the other by showing direction, which is our slope conversation. So this is the linear pattern with 2 points app.